Hello, welcome back to AutoCAD. AutoCAD software can also be used for product modeling and visualization. In this tutorial video, I'll explain the procedure to create and visualize the 3D model of this iron box using simple solid modeling techniques in AutoCAD. This is the fully rendered view of the iron box. The rendering is performed using AutoCAD software. All these things and more is coming up, so stay tuned. In fact, this iron box is made up of various components. We have a handle on top, then a rotating knob, then the main body of the iron box, followed by the base at the bottom. So let's create these components one by one. We will start with the base at the bottom. Even the base is made up of two parts. We have a bottom plate and a top plate. When you look at the bottom plate, you can see that it is made up of a particular profile. So let's go to the top view and take a look at this profile. So let's plot everything in centimeters. Here the length of this profile is given as 25 centimeter and the width is given as 14 centimeter. Before you create the model, make sure that the 3D modeling interface is selected. If it is not selected, just select 3D modeling from the interface switcher. Now click on the application button, drawing utilities, and click on units and change the insertion scale to centimeters. Now you can draw a line starting from here. Activate the ortho mode on, then type the distance 25. Now it's too small. Now we can just zoom in to see it properly. Now repeat the line command and draw another vertical line straight down through a distance of 14 centimeter. Now I'll give move command to move this line with this mid as a base point and this end point as a second point. Now click on polyline command at the draw panel and start a polyline from here and turn off the ortho mode if it is not off. Then right click and go to arc option and right click and choose second point option and pick a second point somewhere over here and end point here and the next end point here. Okay, this is the top profile. Next I'll go to modify panel and choose mirror command and I'll choose this as a profile to be mirrored. This is the first point on the mirror line. This is the next point on the mirror line. Okay, just give enter to come out of the mirror command. Now erase the center line. Now go to modify panel and take join and select all these profiles and convert this into a single profile. Next I'll give offset command and I'll give an offset distance of 0.3 and this is select object to offset and side to offset. Now let's go to southwest isometric view to see these profiles in isometric. Next I'll copy the outer profile through a distance of 3 mm or 0.3 cm straight up. So I'll give copy command. This is an object to be copied. This is a base point and I'll keep the cursor in the upward direction. Type the distance 0.3. Okay, now you have got a copy of it. Now we have altogether 3 profiles on the screen. Now let's perform extrusions on these profiles. You know that extrusion is the process of generating a surface from a profile in the positive z axis or negative z axis direction, depending upon the value given. So I'll go to extrude command and select this as the profile to be extruded. And I'll give height of extrusion of minus 0.15. That means in the negative z axis direction. Next, I'll extrude the inner profile through a distance of 3 mm or 0.3 cm. Next, I'll extrude the top profile through a distance of 6 cm. Now we have performed all necessary extrusions. We have created the base. Next, we will create the body from this extruded part. For that, just start with a front elevation. So click on the view controls and choose front. And I'll use a polyline command. Start a polyline from here. Then turn off the ortho mode if it is on. Then right click and go to arc option. Then right click and choose second point. And pick a point somewhere over here. Then you pick a point here. Then move the mouse like this and pick a point here. Now move the mouse straight up so that you will get an arc like this. Now shift right click and choose nearest and pick a nearest point somewhere over here. Okay, then you come to right click and line and turn the ortho mode on and pick a point somewhere over here. Then pick a point here, then come to this point. Now you have to pick a point corresponding to this point here. For that you can just track and pick. Okay, activate tracking if it is not active. For that you have to press F11 function key or else you can just right click at the O snap button and go to settings and activate the tracking. Here, since the tracking is on, I could easily pick this point. Now right click and close to complete this. You can click on the home icon here to go back to the southwest isometric view. Next, go to move command and choose this profile and pick this point as a base point, a random point here, and keep the cursor in this positive z-axis direction and type the value 9. Okay. Next, I'll extrude this profile through a distance of 18 units in the negative z-axis direction. So type -18. Next, you can perform a subtraction. So just click on subtract and choose the main body and just give an enter. That enter is important, and choose this particular object that is to be subtracted. Now when you analyze these edges, you can see that these edges are sharp. So how will you smoothen these edges? For that you have to apply the fillet. But before applying fillets, you have to save this file. So let's save this file using Ctrl S. Okay, it is saved. Because just in case you make any mistake, you can just open the file which is saved. Fine. Now let's go to fillet command. Now I'll go to radius option and I'll give a radius of 1 centimeter. Now it will again ask you for the radius for reconfirmation. I'll give an enter. Now go to chain option. Chain option will let you select connected edges. So when I just click here, all these edges will get selected in one go because these edges are touching each other. Now when you just click here, even these edges will get selected. Now I'll select this edge as well. Now just give an enter. Now you can see that the sharp edges are converted to smooth surfaces. So this is how you perform 3D fillets. When you look at the back of the body, you can see that it is perfectly vertical. In reality, it is actually inclined. So how will you create that inclination? For that you have to rotate the face. So click on rotate face option of the solid editing panel. Now just click on the back face. Now select this 3D solid. Okay, now it will ask you to select the axis. Axis can be defined by picking 2 points. This is the first point on the axis. This is the second point on the axis. Now it will ask you for the rotation angle. I'll give -10. Next, these edges should also be made blunt or smooth. So for that again, I'll depend on the fillet command. Now I'll go to radius option. I'll give a radius of 0.5 centimeters. And I'll select this particular edge. Select 3D solid. Give an enter. This time I'm going to make use of the loop option. Loop option in the fillet command will let you select edges which are in a loop, which are having end-to-end contact. Now these edges are selected. Now just give an enter to accept it. Now give one more enter. And now we have completed the body. Next we will move on to the handle. To create the handle, we first draw a path. Then we will create various cross-section profiles and we will keep at various places along the path. So let's create the path. I'll start creating the handle by first creating the path in the shape of the handle. But that path has to be created right at the middle of the total width of this body. So you have to align the construction plane or XY plane right at the middle. For that, I'll go to Visualize tab, then I'll align the UCS with the front face. Then I'll go to Origin option of UCS command. Then I'll bring the origin right at this point. Okay, now the XY plane is aligned exactly at the mid plane. Next, I'll take a front elevation using a different method. That is by giving the plan command. So I'll give plan command followed by an enter. Plan view in AutoCAD is defined as a view you get when you sit at the top of Z axis and look down towards the XY plane. That means in this case, when you take plan based on this XY plane, it will be a front elevation. So I'll just give an enter because I want a plan with respect to the current XY plane. Current is the default. But if you take a front elevation using the conventional method here, your XY plane will change its position. Now I'll create the path using a polyline. So I'll go to Home tab and I'll use polyline command and I'll start a point somewhere over here. Then turn off the ortho mode. Now right click, go to arc option, then right click, go to second point. And I'll pick a point somewhere over here. Now the next arc segment is drawn to this point. Next I'll create some profiles. But before that you have to align the UCS with the world. So I'll go to Visualize tab and take world. Now UCS is taken to the base. The first profile is an ellipse. So I'll go to ellipse command, take center option, and this is the center point of the ellipse. Now when I'm asked to give axis endpoint 1, I'll turn the ortho mode on. Then I'll type the value 2.5. Then I'll keep the cursor in the downward direction like this, and I'll type the value 1.5. Okay, so ellipse is constructed. This is 2.5, so the total length is 5, and this is 1.5, so the total length is 3. The next profile is a rectangle, and that has to be drawn in a different plane. So I'll go to Visualize tab, align the UCS with the left face. So I'll go to Rectangle command, click the first corner here, then I'll go to Dimension option, length is 3, and width is 2, and click to define the opposite corner point. Now I'll go to Fillet command, and I'll go to Radius option, radius is 1, go to Polyline option, and click to fillet all the corners of the polyline. Next, you can move this rectangle with the geometric center as the base point, then shift right click and choose nearest, and choose this nearest point as a second point. Next, I'll copy the same rectangle with the geometric center as the base point, and the second point is the end point. Now this rectangle has to be rotated about the x-axis. To make things more clear, I'll bring the UCS origin to this point. Now I'm going to rotate this rectangle about the x-axis. So the command is rotate 3D. And this is a profile to be rotated, and the axis is X. And this is the base point, and the rotation angle is 90 degrees. Now we have 3 profiles altogether. Let's take a front elevation. Now I'm going to just rotate this profile so that it will get properly aligned along this path. For that, just go to Rotate command, select this profile, and use shift right click and choose the geometric center as the base point, and just give a rotation like this. Next, you give Rotate command and select this profile, choose this as a base point, and keep the profile in this orientation. Now let's create a loft surface connecting these 3 profiles. So I'll click on Loft and select this as the first one, second one, and the third profile. Now it has created a surface, but I need that surface along this path. So just give an enter and select path option and choose this path. Now we have created the shape of the handle. Let's go to shaded representation. Now you can see a transformation taking place from one shape to another. Here you can see 2 few lines in the wireframe representation. So change the value of a variable isolines. This variable controls the number of lines in the wireframe representation of a solid model. Now give the value 10. Type RE to regenerate the screen. Now we will get optimum number of lines in this to get a better understanding in the wireframe representation. So this is how you make the handle. Next, we have to create 2 types of knobs in the iron box. One is a rotating type knob, another one is a pushing type knob. So I'll align the UCS to the world so that it will go to the base. Now I'll draw a circle over here with the dimension of 2.5 because that is the radius of the knob. Next, I'll go to plan view. Now I'll draw a line from this quadrant through a distance of 0.05. Then I'll give offset command to offset this line through a distance of 0.1 to both sides. Select object to offset, object side. Then erase the center line. Connect these 2 endpoints using a straight line. Then give stretch command, type the letter S and stretch these 2 lines slightly downwards. Then connect these 2 endpoints using a straight line, and you can join all these lines. Now this is the right time to extrude these profiles. So you can just go to extrude and select the rectangle as well as a circle and give a height of extrusion of 0.5. Now go to southwest isometric and take a look. Next, we have to create multiple copies of this extruded rectangle along the circumference of the circle. So the command is array. So choose array and select polar array from the modify panel and select this rectangle and choose the center of the circle as a center point of the array and just give an enter. we will increase the number of items in the polar array. So select the array object, change the items from 6 to 40. Next we will position it on the right location on the top of the body. For that, just go to the top view, representation to wireframe. Now move the knob with the center as the base point and mid of this edge as a second point. Now move it once again, just right click, repeat move, select the same object leftward and position it suitably at the right location. Now take a front elevation, move it slightly upward, and you can also rotate it with the center as a base point. Turn off the ortho and O snap, and you can keep it like this. Again move straight down in such a way that it will just touch the top of the body. Okay, so this is how you make the rotating knob. Next we will create the push type knob. I'll change the uses to world. Then I'll go to ellipse command and choose axis and point. Click the first corner here, then turn the ortho mode on and give a value of 1.5. Now keep the cursor in the X direction and type 0.5. I'll extrude this through a height of 1.5. Next I'll go to fillet command and give a radius of 0.3. And I'll select this edge, then give an enter and one more enter. It's filleted. Next I'll go to front elevation and use move command to move this push type knob from the existing location to a suitable location on the handle. Now when you look at it, you can see that it is slightly dislocated. So take a top view and adjust its position. So give move command, select the object, click a base point somewhere over here. After activating the ortho mode, move it and keep it in a suitable location. Now to southwest isometric, shaded representation. Now we have completed the 3D modeling part of the iron box. Next we will assign some basic finishes and we'll perform a rendering. To perform rendering in AutoCAD, you have to access Material Browser. This interface can be obtained either by typing rmat command using the keyboard, or else you can go to Visualize tab and click on Material Browser. When you enter the browser, you will see a number of materials in the material library of the software. You can just click on this arrow to go through the list of materials you have. Now I'll click on aluminum and browse all the way down, and I'll choose this particular aluminum, that is metal aluminum. I'm going to give this material for the base of the iron box. So just select the base. You can just zoom in this area and you can select the base and right click and assign to selection. And if you want to see the presence of this material, you have to change the visual style to realistic. Now you can see the metallic finish. Next I'll click on the plastic finish, then scroll all the way down and I'll choose a particular finish. Let it be this finish, that is plastic. Now I'll select the body as well as the handle, keep the cursor on this material, right click and assign to selection. Now that finish is applied. Now if you want, you can change this finish. For that, just double click on the material and you will see the parameter related with this material. You will see RGB, that means red, green and blue components of this color. Just click on this, you will get a color selector and you can choose any desired color now. Thereby you can change it. Now this is what I want. Now select the objects again and right click and assign to selection. Hence in AutoCAD, you can directly apply the materials that are available in the material browser, or else you can edit an existing material, or you can create a material right from the beginning. Next, I'll create a material that is to be assigned to the rotating knob. For that, I'll just right click on the global material, which is the default material, and click on duplicate and just double click on the duplicate and change the name to knob just to identify. And I'll assign an image here in the image slot. Just click on the image and select iron box knob. I'll just right click and open that image So this image is actually created in Adobe Photoshop. You can download this image from my website sabircad.com. Just click on the tutorial files link at the lower right side of the home page. Now I'll select this image and give OK. Now I'll double click on the image to get the various parameters related to this image. Now here the size of the image is presently 30.5. Actually it has to be 5 cm because that is the size of the node. Now I have brought it down to 5 cm. Just close this and this one. In AutoCAD you can assign material after performing a face selection. For that you have to just hold down the control key and click on the top face to select only that. Right click on this assign to selection. Now we have assigned the node material on the top face. Now I'll close the material browser. This is the right time to render this. Now click on visualize tab. If it is not active, select full shadows and you can go for high quality. Then render size, I'll select full HD 1920 by 1080 pixels. Then click on render. It will initialize rendering. You have to wait for some time to get the result. Now this is how the fully rendered image will appear. So now we have completed the tutorial on 3D modeling and rendering of an iron box. Hope you have enjoyed doing it. You can download the image files and the 3D file from my website sabircad.com. Just click on the tutorial files link. Thank you so much for your patience and time. Please hit the like button of this video if you liked it and subscribe to my channel if you haven't subscribed already. Until I see you in my next video, bye bye and take care. May God bless you all.